So welcome to today's webinar, finally. On behalf of the National Transit Institute, I welcome everyone and thank you for participating and thank you for your patience. The National Transit Institute develops, promotes, and delivers training and education programs for the public transit industry in the United States. Today's webinar is based on TCRP Synthesis 130, Battery Electric Buses, State of the Practice. Today we have Jason Hanlon of the Center for Transportation and the Environment, Jeff Hyatt from APTA, Sean Richardson from FTA, and Roland Cordero of Foothill Transit. Today's session, assuming everything functions, will consist of presentation of the material followed by a Q&A at the end. The Q&A will be in the chat box at the bottom. I will facilitate the questions. If there's a speaker who's not speaking at the time and wants to jump into the chat box and answer the question, please go ahead and I'll try to keep track of this as we're moving on. If you haven't already printed out a copy of the presentation, you might want to do that, especially considering the technical glitches we're experiencing today. You can follow along hard copy. You can download that as well as the report itself on which the webinar is based in the upper left-hand corner where it says handouts. And in the notes section, you can also get the handouts, but those links need to be copied and pasted in your browser. They are not clickable right there. So that does it for me. I believe that Sean wanted to say a few words. Sean?
Yes, hi. Thanks, Lori. I'm Sean Richardson. I'm the FTA liaison to this synthesis project, and FTA assigns a liaison to every TCRP research project to ensure that there's awareness between our organizations. So first I'd like to thank Lori Glickman and the National Transit Institute for hosting the webinar. FTA has supported and worked with NTI for many years, and they're a really great organization, delivering a whole range of transit training. All kinds of courses are offered, and transit agencies can even host a course if they want to. So I do encourage everyone to reach out to NTI for your transit training needs. Second, I just wanted to say make a mention of the Transit Cooperative Research Program, or TCRP, which is what provided this research effort. It is also supported by FTA. It's a cooperative program, meaning that it works directly with the industry to both define and develop the research that the industry thinks is important. So I'd like to encourage everyone to check out TCRP website and get involved with TCRP because it really produces some fantastic products. And with that, I will turn it over to Jason. Jason.
Yeah, hello everyone. This is Jason Hanlon from the Center for Transportation and the Environment. Let's see. Well, we'll start with the webinar agenda. So this webinar is for TCRP Synthesis 130, State of Practice for Battery Electric Buses. This is a quickly evolving industry, and it's really progressed over the last 4 years. So this was obviously a good time to take stock in what we're doing and collect all the information we have available to us and see where we are and where we need to go. So that's what we're going to go forward with. The structure for today's webinar, I'll be giving most of the synthesis findings, but like Lori and Sean said, I do have some of the TCRP panelists with me to help carry us through the presentation. If you guys aren't familiar with the TCRP process and the synthesis process in particular, there is a panel of industry experts across the industry, stakeholders that come together, define the objective and the scope for the synthesis, and also help to guide and oversee it throughout the process and periodic reviews. So Jeff, Sean, and Roland were actually on that panel with a bunch of other folks, and certainly appreciate their work in pushing this through. So today we'll go through introductions, kind of go through about the synthesis findings, agency experience. And what this is going to do is really follow the charge of the synthesis process, which is to pull information and data from what's available out in the industry through literature review, survey, as well as case examples. So this is going to kind of mimic that. Next slide. Did you guys see the introduction?
Yes.
Okay, good. So I guess I'll start off and just give you a little bit of background about CTE. We're a nonprofit 501(c). Our mission is to advance clean, sustainable, innovative transportation and energy technologies. And we do that through carrying out research, demonstration, and deployment projects. We've been doing that since 1993, so we've seen a lot of the progression through the industry, and we've done, while we do a lot of work with medium and heavy duty vehicles, transit is a great platform to demonstrate new technologies and clean technologies. So that's where we've seen the most advancement, I think, in the sector. We do have offices in Atlanta, Berkeley, LA, and St. Paul, and we have been involved in one form or another with over 30% of the zero-emission bus deployments in the United States through, managing the projects, carrying them out, as well as on the consultant side, and helping agencies deploy these technologies. So, actually, Roland, do you want to introduce yourself real quick?
Sure. Hi, my name is Roland Cordero. I'm the Director of Maintenance and Vehicle Technology at Foothill Transit. My main responsibilities are to ensure that our fleet of buses are properly maintained. We contract out our services to Transdev and First Transit. I'm also, one of my biggest projects is the fleet electrification in Foothill Transit. I've been involved with that project since 2010. And we've seen a lot of lessons that we've learned through the last 8 years, and we're progressing to 100% fleet electrification, and there are a lot of issues that need to be addressed in that process, mainly the planning and operations side, the impact of fleet electrification on the operations of the transit agency. So.
Okay, and Sean, you've introduced yourself, so Jeff, do you want to introduce yourself and get right into what the synthesis is about?
All right, thanks, Jason. My name is Jeff Hyatt, and I'm the Assistant Vice President of Technical Services and Innovation at APTA. And APTA works with TCRP and as a disseminator of TCRP publications. And APTA also serves as a liaison on different panels to help guide some of the research in different areas as well. And so for this particular synthesis, which was completed, just a little bit of a background, but one of the things that the panel who as Jason mentioned, that develops the scope and selects the contractor. And the final scope that the panel came up with for this particular report really was because there are a lot of transit agencies that have a lot of interest in understanding the benefits and challenges associated with introducing and operating battery electric buses in their fleets. And we've seen some locations, some cities, and some states that are putting mandates on going to zero emissions by some year, 2028 or 2030, 2035. And we've also seen a lot of agencies operating these fleets, with more than 20 that are operating these buses currently right now. But there's a lack of unbiased information for agencies as they evaluate the deployment of battery electric buses. So as transit systems consider these deployments, it really is advantageous to really look at where the state is and look at the experiences of those that already have them in their fleet, because that is very critical and valuable, we think, to transit systems as they look to operate these types of vehicles. As you can see on the screen, the users for this are transit agencies, those who manage fleets, funding agencies, policymakers, OEMs. So that's everyone really basically who's involved in this space can utilize the information in this document. And how this was put together, Jason and his team, they reviewed literature, they sent a survey out to agencies, you can see 18 agencies responded, and they also looked at some different agencies who had some in operation, which you'll hear from Roland at Foothill Transit coming up on as a case example. And Jason, if you can go to the next slide, please, or whoever's advancing.
I can.
I don't have that capability. So just what this synthesis is just a snapshot of the current state and practices, and everything is rapidly moving. We are in October of 2018. I will say a lot of the information that Jason and his team gathered, was a year ago. You'll see, the challenges are still there, so it's nothing outdated. But using the literature review and the survey results, they were able to identify some of the gaps, and that's what's going to be shown, and Jason will talk about, and also just some of the industry needs, where we should be looking for, where the needs are, that will then help us where the synthesis is not, and that's help us to look forward. So it's not looking forward, it's not predictive, it's also not promoting any product or service, and it's also not offering any recommendations or best practices. It purely is just a synthesis of the state of the industry at this time. The next slide, please, Jason. So you can see there are a lot of topics that had to be reviewed for this synthesis, and I'm not going to read through all of them because you have a copy of this presentation, but it really looked at it from the planning of operating these types of vehicles to the service, maintenance, operations of it, and then also the costs and benefits. So, looking at, some of the funding and some of the other costs associated with operating and putting these battery electric buses in service. I think I'm going to turn it back over to you now, Jason.
Okay, thanks, Jeff. So real quick, this obviously is a very broad charge and synthesis. So today I'm just going to try to provide a summary of the findings as well as a sample of some of the results, and really to kind of describe some of the resources that we used so that you guys can even go look at those if you want to, in order to build upon what I present today. So the benefits and challenges will basically start at the top here. I think most of you guys know these, but they're worth revisiting, and they were certainly things that came out as we pulled all of this information. Benefits of battery electric buses, of course, no tailpipe emissions. Well-to-wheel emissions are improved. No dependence on foreign oil. Improved experience for riders and drivers, and potentially lower operating costs. The reason I say potentially is because it really depends pretty heavily on a lot of factors, including utility rates and how you set up your fleet and your individual environmental conditions. So the challenges, and I call these challenges because almost all of these can be overcome as we progress within the industry. There's really nothing that is going to be a complete barrier, and if we do see the battery technology improvements, then we should be able to overcome all of these. But they are, of course, higher capital cost, range limitations with respect to existing technologies, diesel and CNG. Same with refueling times. They're going to be slower. Charging is slower than fueling existing vehicles. Electricity rates are higher in some locations, and there are complicated rate structures. So like we said, this is a rapidly growing industry. Starting at about 2010, we do have a couple of operators that have been operating battery electric bus fleets for almost 20 years, but things really got started in earnest around 2010, and I'll walk through some of those drivers. But today, I think, well, actually, as of early 2017, there was quite a bit of growth, including 600 battery electric buses delivered or on order, so that's awards or delivered, involving over 70 agencies. And where we are today, almost everything I'll give you today is captured within the synthesis itself, but compared to the, or early 2018, those numbers are about 1,200 U.S. sales and deliveries, as well as approximately 130 transit agencies. So it's continuing to grow. International activity is over 170,000 battery electric buses deployed. Most of those are in China. But Europe has also had quite the growth, and this is as of 2015, with 956 buses delivered or on order. Like I said, there's a number of different products on the market. I won't go through all these, but the important takeaway here is that there's the industry and OEMs in particular have come up with a lot of different solutions to kind of meet the needs of each individual transit agency and really to address the range and charge time challenges associated with these buses, so that we can, achieve all the benefits. And there's a number of ways to charge the buses, and there's a vast difference in energy storage or onboard battery storage for the vehicles. In this particular case, between these 13 different products, battery sizes range from 76 kilowatt hours all the way up to 660 kilowatt hours. So there's a number of different options for transit agencies to meet their needs. And I'll get into, in a little bit, the planning considerations for those. What we also see right now is, even though we do have a lot of participation within the industry, they're smaller fleets. This is a histogram for the number of transit agencies that are deploying battery electric buses, and the fleets are generally in the 1 to 5 size range, 6 to 10. But there are a couple of fleets that are 20 plus battery electric bus fleets, but even today it's still not a lot. So I think we see a lot of transit agencies dipping their toe in the water and trying to feel things out and really just learning. And on the next slide, environmental challenges. So I just kind of pulled a couple of stats just to reconfirm one of the reasons that we're doing this and interested in the zero-emission technology. Buses consume 98,000 barrels of petroleum per day in 2014, which is equivalent to 4 million tons of carbon dioxide. And in California alone, heavy-duty vehicles emitted more particulate matter than all of California's power plants combined. Trucks and buses also contributed to more than 30% of the state's nitrogen oxides. Now, the majority of that is trucks, of course, but it's still important to stay focused. And in terms of environmental benefits from buses, this chart's actually from a Union of Concerned Scientists study that was done in 2016. The 4 transit buses life cycle well-to-wheel global warming emissions were almost 75% less than diesel and CNG buses, and that is at the existing California electricity mix, or even considering a landfill gas, natural gas mix for production. And also on the particulate matter side, it's almost 20% less than diesel and CNG buses. In terms of efficiency benefits of the buses themselves, they've proven to be over 4 times as efficient as CNG, diesel, and even hybrid buses. This data actually came from Altoona test results. There's a lot of good information and data in the Altoona reports that can be mined, and so this is where we got this. The data from these reports are done on a basically standard test methodology, and if you can, when you find fleets that offer different powertrains across the same product or platform or chassis, then you really can start to compare and understand the effects of the difference in powertrains. And so this is what we saw, basically across all of the test duty cycles. And by the way, I think you guys know those efficiency improvements are due to the extremely efficient components within the electric powertrain. There is a energy conversion loss for diesel and CNG engines that has to be accounted for, and electric buses can also take advantage of recovery of braking energy through regeneration. Also from Altoona results, there is measured noise reductions within the bus. Across most of the bus, from the front to the rear, sound levels have been reduced below 70 decibels. So that's another good finding. So the battery electric bus implementation drivers. So this is kind of, well, as you guys know, there are both incentive programs as well as regulatory programs that are driving a lot of the implementation across the country. Early on, that started with a lot of the programs that came out of the FTA research office, including the National Fuel Cell Bus Program, as well as TIGR program, that helped support the development of these buses and really put prototypes out in limited demonstration. And then now we're seeing, well, there are also a few various state grants and local grants that help early on. So yeah, I was kind of going over the incentive programs as well as regulatory programs. I think you guys heard up to the point where I was talking about the LONO and HVIP program to cover, are now being used in the really more of the deployment phase as opposed to demonstration phase. And they are designed to cover the incremental cost of battery electric buses as well as infrastructure. And of course, we also know that a lot of the agencies in California are working to, in anticipation of the CARB Innovative Clean Transit Regulation, which will require that all fleets be 100% zero emission by the year 2040. So, in a lot of the material and survey and other reports, we heard from transit agencies that say, that we're saying that we're trying to get ready for this. Let's see. In terms of charging methods, I'm not going to go through the details behind the individual charging methods, but there are three predominant methods, and there's some variation within those methods, but if you go to the synthesis, you can kind of see the pros and cons and planning implications. They must be considered, certainly with a lot of the other variables that have to be considered, which I'll get into in the next slide. But those are really plug-in charging, which is primarily used at the depot or yard or maintenance facility. Then there's overhead conductive charging, which is a fast charge method that's done en route, as well as the wireless inductive charging that's also done en route or while the bus is in service. So this is a pretty important slide, and it really is intended to cover a lot of the information within the synthesis, but it's really a summary of all of the considerations and variables that a transit agency has to consider when planning on deploying a battery electric bus fleet. And they're interrelated, they all affect each other, and they really need to be considered holistically at the outset of any program. In terms of route characteristics or bus blocks, you have to consider the length, the amount of time that the buses are going to be out on route, the duration, in terms of how long they'll be out, the schedule and frequency. Duty cycles also have to be considered. They have a big impact on the energy consumption for the vehicle itself. Speed, grade, ridership, all factor in pretty heavily to energy consumption, which I'll get into here in a minute. Operating environment, ambient temperatures can certainly have a big impact. And as we've discussed, you have to consider a lot of the different options associated with battery sizes on board the bus, passenger capacities, because the increased weight of the buses can affect passenger capacity, performance, and how the buses are tuned, the capital cost, and of course the operating cost. Anticipated capital cost and operating costs should all be considered and play a role. Charging specifications in terms of methods and power, even within those three charge methods, there are options for charging at a range of power. And of course the infrastructure requirements. In terms of electricity supply, this carries a lot of discussion in the synthesis, primarily related to rate structures. They can be complex in certain areas and include, in addition to energy cost, demand cost, and time of use cost. So, the important takeaway for all of this, without getting into each of those, is that there's a bunch of decisions that need to be made and are unique to individual agencies. And you have to plan carefully in order to do that. Transit agencies approach this are currently approaching this in a few different ways, whether it's through trial and error, whether it's through consultants and having consultants come in, whether it's listening to OEMs and having OEMs kind of plan out how they should be, the types of products they should be getting and how they should be deploying. We at CTE advocate primarily for simulation, bus modeling and simulation methods to be able to understand how the different products are going to operate on a particular route under a variety of conditions, and how, which one's the most optimum to use considering all of those conditions. But you have to take a strategic, coordinated approach. Whatever method you use, you need to make sure it's coordinated with all of the stakeholders. And we heard this a lot in the synthesis, that you really early on have to involve bus OEMs, utilities, your operators, unions, communities, your champions, your executive boards, as well as regulatory agencies. So I think that's the kind of bottom line there. So on capital costs, what we found, there was limited data publicly available for bus capital costs, but the information from, sorry, I don't have this reference, but the top bullet actually comes from the NREL reports for Foothill. NREL reports are an excellent source of information, especially on the Foothill fleet, because that one started early. You'll hear more about those experiences from Roland. But those costs over the time that they were deploying buses or have been deploying buses and continue to, from 2009 to 2015, dropped from 1.2 million to almost 800,000 for the fleet. That's fairly representative from what we see. What I also included and pulled forward was the survey data, because I think it was appropriate here, and it also seems to capture pretty well the cost, not just for the buses, but for the charging equipment as well as installation. The depot charging equipment is right at, on average, about $50,000 a charger, and that's really for DC charging primarily. AC charging, where the charger itself, the inverter, is on board the bus, is significantly cheaper. But for DC charging, EVSE, oh my gosh, I just lost one. You guys can still hear me, right?
Yes.
Yes.
Okay. Someone might have to advance the slides. You see the installation cost, and on-route charging equipment is right at about $500,000. And that is also going down. That is predominantly for the kind of inverted pantograph or blade style charging. And construction costs change, while they're about $200,000 on average, they can vary significantly based on your site conditions. Next slide. On the operating costs, those costs were certainly difficult. That information was difficult to obtain. There's just limited numbers out there. There is some information in the NREL reports, which is good, but it's only a few data points. And there's also limited data associated with component reliability. We're still seeing some evolution. Well, in particular, I mean, you guys saw the graph, so we're still in the early years of battery electric bus deployment. So we just simply don't have a whole lot of data that's available. But also, the buses are still evolving, and we're seeing components evolve, OEMs optimizing components or changing components. So that's kind of driving a lot of that. But I think you see, I also brought forward the survey results. You see the scheduled maintenance cost as well as unscheduled maintenance costs, but you also see a big variety from the reporting agencies in terms of what their maximum and minimum costs were, and I think that just goes to show that we don't quite have a handle on those costs. But we also see electricity costs vary pretty widely based on, of course, your rates and in particular how you decide to set up your fleet. Next slide. On fuel economy, this is a big one. I think what we hear a lot is to really kind of plan for about 2 kilowatt hours per mile in terms of fuel economy. And the data that we pulled and used in the synthesis was from a few different sources. Again, from Altoona data, which really ranges and suggests, about 1.6 to 1.9 kilowatt hours per mile. But Altoona testing is done really on a flat route with no auxiliary loads, no HVAC loads, and it's also done at seated load weight. So those are really kind of your best case fuel economies. The Foothill data from the NREL report shows over roughly 2.1 kilowatt hours per mile, but that's over quite a bit of data, over almost 400,000 miles. The Foothill location in California is on the mild side on coastal California, in coastal California. So, but what we also pulled was data that shows in northern climates, and this is a good amount of data from early 2015 all the way through 2016 for two different fleets that show energy consumption of 3 to 6 kilowatt hours per mile. And this is I do say worst case here, but this can be fairly standard, and this will certainly impact your range. In some cases, of course, it can half your range. So this really needs to be planned for and understood. Next slide. Utility rate and fuel cost impact. So what we see here are two charts from a good report, but we have to be careful here, and these aren't, I wouldn't take away from this that this is going to be cost for any given fleet. It's one set, it's one study. Assumptions for this chart, and it's basically showing fuel cost in dollars per mile and comparing electric cost to diesel and CNG cost. But the assumptions here are really behind this study are $4 a gallon diesel, among other things, 2.5 kilowatt hours per mile, and we just talked about the importance of considering fuel economy, and 10 cents per kilowatt hour electricity rates. And on top of that, you can see at the top the difference between the two charts are the demand charges. So while you can't really make assumptions about how the numbers, how they'll look in your fleet, what you can pull from this is that a few things. Number one, it's important if you do have demand charges, it is important, utilization is important in order to spread out those demand charges. You can see how that light shaded area reduces as the number of buses increases. It also shows in the last column the time of use impacts. So these are all components that go into a rate structure. I'm not going to go into those today, but they are explained in the synthesis. So I would encourage everyone to kind of look into those. Next slide. Just real quickly, one thing that I think gets lost and a lot of people don't mention, benefits of converting a fleet to electric. is the stability of electricity pricing. According to the U.S. Energy Information Agency, which has good energy cost information and data, there has been a steady 3.5% annual growth rate for electricity versus spikes in energy pricing for diesel and, well, actually gasoline and diesel and natural gas that can spike between 200 and 300%. Next slide. Challenges. So we came across some good in looking at international data and information. The challenges, and this is word for word from a Zeus report. Zeus is the European electric bus program, and the challenges were very similar to what we deal with here in the U.S. And so I put those in here word for word just so that we can kind of see those and compare those to what we are doing. Real quickly to go through those, it's the higher upfront cost of electric buses, we know that. The importance of identifying suitable technology solutions for specific local operational contexts. So we've been talking about that. It's very important to plan accordingly. The necessity to review. Can you guys still hear me?
Yes.
Yes, I think
Okay,
it was
good.
somebody else coming in and out, honestly.
Okay, just wanted to make sure. The necessity to review current procurement and contractual frameworks. We've been working on those procurement guidelines through APTA working group. We should see procurement guidelines out of that working group for battery electric buses in particular over the next few months. We've also been addressing procurement barriers, barriers to procurement and contractual kind of strategies, such as implementing changes under FTA policy that allows for battery leasing in order to get the capital cost of battery electric buses down and take advantage of the potentially lower operating costs. So we're addressing that challenge. The requisite to standardize charging interfaces, we're working on charge standards. I'll talk about that in a second. And the need to develop trust and cooperation with utilities. So this obviously came up quite a bit over researching the synthesis, the importance of working with your local utility early and often in the process. Next slide. Next slide. So a few of the needs, and then we'll get into the synthesis findings. But one big one right now is charging infrastructure at scale. As an industry, we are still working to address this need and challenge. And I don't know that we're completely there yet. The challenges are related really to converting to a full fleet of electric buses, or a significant quantity. And those challenges are related to understanding infrastructure requirements and land use and space constraints, and that's primarily dealing with potentially having to install substations, transformers, switchgear, a lot of the things that transit agencies may or may not have had to deal with in the past, but also how you set up and where you set up those chargers and which charge method you're using to optimize the space within your yard or your facility. It's also in terms of land use. If you are doing opportunity charging or en-route charging, one of the biggest constraints is actually getting the getting the land to deploy charging infrastructure and rights to property in order to deploy those. So this is one of the bigger constraints that we've been looking at. Grid demand impacts. So if you look at the chart to the right, you see 50 electric buses is a significant load on the grid. This is at 60 kilowatts of charging, adds up to 3 megawatts. So it's certainly a significant load to deal with, and that has to be understood, as well as fleet staging, how you're going to charge, and if you're doing depot charging, plugging in the buses, the labor requirements associated with plugging and unplugging buses, and then, of course, maintaining operability during power outages. But there's still a lot of work that needs to be done here, and there really wasn't a lot of available information within the literature addressing this. Next slide. We talked about the needs for understanding operations data or gathering operating data, but as well as understanding utility rate components and variability, but also from a life cycle cost assessment perspective, there was very little in the way of methods or methodology for collecting and analyzing life cycle costs, as well as the actual cost or the cost, what kind of costs we should expect in order to feed into those assessments, which is really important, of course, for comparing your battery electric bus fleet to your existing fleet, as well as making decisions among what's available out there. Next slide. So in terms of charge standards and guidelines, this of course comes up quite often throughout the literature and responses, is the need for interoperability for plugging in buses. And on the plug-in side, this so where we are actually today, but you kind of describe these standards a little more in detail in the synthesis, but J1772 SAA standard is in place for DC as well as AC low power, but that's the AC side is not typically used in transit. Of that standard is not typically used. SAA J3068 for AC charging, higher power AC charging was just released about 2 months ago. So that's another combo connector that's available. Overhead conductive is being worked on through the J3105 committee. That will include multiple configurations, such as inverted pantograph, bus-mounted pantograph, as well as the blade style and some other styles. So that's in progress. Hopefully early next year we'll see. And on the wireless side, that standard is also being worked on. And I previously mentioned the work that the APTA Working Group Committee is doing to develop the standard bus procurement guidelines for zero-emission buses. That will be staged, so what we'll see first released is procurement and really technical specifications for procuring the buses themselves. The next phase will get some help on, will provide some guidelines on procuring and deploying the infrastructure side of things, and then we'll start to work on things like fuel cell buses and other items. But those are being worked on in the industry, so that's good. Next slide, we'll go through I've just picked a few different findings from the survey itself that I'd like to kind of talk about a little bit. Let's go to the next slide about the survey. It was a exhaustive survey. It was a big survey because we touched on so many different topics. But we were able to get a response rate of 86%. We really focused on getting responses from agencies across the country, both in the north and the south, small agencies to large agencies, all at varying states of deploying their battery electric bus fleets. Some were in the procurement phase, some were actually well into deploying and operating battery electric buses. And that was, running the range from 2 to 18 battery electric buses in service, in peak service. Next slide. So this is a good slide. This shows the maximum daily range that the buses are being operated under and the charging strategies that are being used. This is for 10 of the agencies that responded. These were really 10 agencies that, the 10 agencies that actually had experience with the buses en route. But we see two takeaways from this. Number one, most of the agencies are putting battery electric buses on kind of their lower hanging fruit routes, the ones that are operating around 100 to 200 miles or even less than that, in order to kind of test those out, make sure that, minimize their risk in terms of range of the buses, and really understand what the buses are doing. But what we also see is for those longer routes, the agencies were choosing to utilize en-route charging, whether en-route conductive or en-route wireless charging. You can kind of see those agencies, that was the approach that they were taking. We have more recently seen the emergence of the larger battery buses that are intended to be depot charged, but we really haven't seen the results from those yet. So next slide. In terms of how agencies are procuring battery electric buses, it's a wide variety. They're going through competitive grant opportunities with suppliers in mind, and really already having their fleet kind of defined in terms of the bus that they are using as well as the charge type. But we also are seeing agencies that are releasing procurements or that are releasing RFPs themselves with funding that they have available. And we see agencies that are doing a combination of these things. So next slide. In terms of, in terms of how agencies are procuring infrastructure, we're also, at a unique place in deployment of these fleets in terms of agencies having to basically procure both the buses and the infrastructure at the same time, and trying to deal with how that's done. And we see that the first section of this chart basically shows that there was most agencies actually procured the vehicles with the infrastructure under the same contract, but we did have agencies that were doing that separately. And the other two bar charts within that chart, we also see the importance of involving local utilities early when making infrastructure decisions, and as well as carrying out the deployment. So that was a pretty critical finding. Next slide. We wanted to know if agencies were planning to scale up the fleet as they were deploying these initial fleets, and was kind of half and half. Most of the agencies did try to consider scaling up the fleet and understanding those implications. But I think a lot of them were also, and we heard this, a lot of them were really testing the waters and using these early fleets as trying to learn from a deployment in terms of how to move forward. We also heard a mix of anticipated issues with scaling up. And you can kind of see that it basically went back and forth. About half the agencies anticipated issues related to having adequate space for the charging, related to having adequate power, and related to having adequate resources as they scaled up. Next slide. So we also wanted to know how the buses were going out every day in terms of departing and returning in terms of battery state of charge. And we broke this out. Yes?
I think you're one slide off.
Okay. Can you go to operations experience, battery state of charge?
Which way is it? Forward or back?
It's
The other way.
That
There
one?
you go.
yeah. It's right before the summary. Or no, I'm sorry.
One more?
I've actually lost contact with the...
Yeah, your name isn't showing up anymore. It says survey selected results, operations experience, battery state of charge. The next one or that one?
Yep, that's it. That's it. So in this one, we broke these out between who was charging at the depot only versus en route, and how they were departing as well as returning from service. And if they were charging at the depot only, we saw that they were certainly topped off in that 95 to almost 100% range. For the buses that were being charged en route, we saw that they had flexibility in being able to go out and top off en route because they typically had fast chargers en route. So that's kind of what you see in those first two sections. When they were returning from service, kind of similar, the en route, the buses that were being charged en route came back with 60 to 80% state of charge. So requiring very little, if any, charge at the depot, charging at the depot. Whereas depot-only charged buses were coming back with anywhere from 28% to 62% state of charge. Let's see, next slide. In terms of cost comparisons, this was generally as expected. Responding agencies stated that the capital cost of their buses were typically greater than existing diesel and CNG buses. The operating and maintenance costs, we about, I think, let's see, almost 50% of the agencies responding stated that their operating and maintenance costs were actually less than existing incumbent technologies. But we also saw that about 30% of those responded that they weren't sure. So this kind of gets back to that that issue of not understanding or tracking operating and maintenance costs. In terms of life cycle costs, it was even worse. There were about 70% of the agencies that just really weren't sure what their life cycle costs were or were expected to be. So I think one of the findings was really that we need to establish methods as well as structures for calculating those life cycle costs, especially as we continue to get data back from the industry. Last slide on the actual survey itself was overall satisfaction. We'll leave on kind of a high note here. On a scale from 1 to 10, 77% of the respondents were satisfied with their battery electric bus fleets and ranked them higher than 4. And most of those were very satisfied, so ranking between 8 and 10. 86% of the reporting agencies do plan on purchasing more battery electric buses. And while one of the agencies that we surveyed had already gone fully electric with their fleet, 3 other agencies responded that they intend to be fully electric by 2018, 2025, and 2030. And finally, one agency actually reported that they plan to replace their 17-year-old battery electric buses with new battery electric buses very soon. So that was good. That was encouraging. So we kind of walked through the literature review results as well as the survey review results. We also did case examples. We selected 5 agencies and did interviews to really get both kind of confirm some of the data that was submitted, but also to get kind of their thoughts and anecdotal and subjective reports, as well as their lessons learned for deployment of those fleets. And one agency in particular was Foothill, which is, an early adopter, and Roland will walk us through kind of some of the findings or some of the results of the case example that is in the synthesis and their findings. Roland, do you want to take it from here?
Okay. Let me see if I can advance this.
I'm going to reconnect while you're doing that.
Roland, can you control the screen, or do you need me to click?
Let me see. Yeah, I can move it.
Okay, good.
Okay, hi. So Foothill Transit started back in 2010 with 3 Proterra 30-bus electric buses. I'm just going to go through what's on the slide right here. By the time we had the synthesis done, we had 17 Proterra fast charge electric buses. These all had a range of 35 miles. Currently, we added 14 40-foot extended range Proterra E2 buses with a nominal range of 251 miles. We received those buses last December, and some of those buses are really not operating at the time because we're still working on our in-depot charging station at the Arcadia Yard. Total fleet miles, we're running 29,000 miles. For the last 10 years, we have over 1.5 million accumulated miles on our electric fleet. This is mainly on line 291. The traction batteries, again, 72 kilowatt hours of energy. The range is 35 miles, which confirms the NREL study of about 2 kilowatt hours per mile from the energy of the battery electric bus. We have a charging station at our Pomona Transit Center, which serves line 291. And the buses are charged at that transit center every hour on their round trip, and they get fully charged from 60% state of charge to almost 100% for about 7 minutes while they're stopped at the transit center while passengers are boarding and alighting. We also have two overhead chargers at the Pomona Transit Center. Last year, we installed 2 more overhead charging stations at our Azusa Intermodal Transit Center, where we will operate the 14 extended range buses on line 280. That's a 22-mile round trip route. The average route length, again, on line 291 is 16.1 miles. Average speed is 10.6. The bus price, when we started the project back in 2010, it cost us over $1 million per bus. Now we're at about $789,000 for base price. With all the additional equipment, we're talking about $823,000. We're able to supplement the federal funding and the local funding that we have to pay for the bus with the HVIP incentive program here in California. We get a credit of about $150,000 to $180,000 depending on the type of bus. Bus price change between our CNG fleet and our Proterra electric bus between $200,000 to $250,000 depending on the equipment and manufacturer. So the HVIP kind of helps bring down the cost variance, but there's still about $100,000 price variance between the CNG and electric. Our charging station at the Pomona Transit Center, when we had that installed back in 2010, it cost us over $1 million per charger. We have 2 chargers, so that's $2 million. Our last installation at the Liaison Intermodal Transit Center, the price has dropped to about $700,000. Line 291. So when we started the project back in 2010, we selected line 291, which is a 16.1 mile round trip to serve the city of Laverne in the north and the city of Pomona at the bottom. The reason why we selected line 291 is because of its short round trip. Again, the bus that was only available for service and transit has only a range of 35 miles. The topography of the route is very level, so we didn't have to worry about hill climbing, not to worry about losing some charge based on the topography of the route. Line 291 is also one of our most productive routes. It serves a transit-dependent community in the south of the route, which is Pomona. It also has access to the transit center, the Pomona Transit Center, with connections to downtown LA, Foothill Transit Silver Street route. It also provides connection to Omnitrans. There are 2 bus routes from Omnitrans that uses the transit center, which allows our community, our bus riders to transfer to another transit agency to head east into San Bernardino. And there are also 10 other routes, Foothill Transit routes that use the transit center. We also partnered with the city of Pomona to lease the transit center and install the chargers for 40 years, allowing us to lease for 40 years without any free of charge. So it's really important to partner with the cities that you're serving if you want to install a charging station. We have also partnered with Southern California Edison in terms of a planned installation of 14 overhead chargers at the Arcadia facility. We've been working with Southern California Edison way back when we started the project in 2010. And last year they submitted a transit charge-ready transport program with the Public Utilities Commission, where they allow Edison to partner with transit agencies to fund the infrastructure, do the design, fund and do the construction work for the charging stations, from the transformers to the meter and to the all the way into the parking structure at our yard in Arcadia. So that helps save us a good amount of money in terms of cost for installation of in-depot chargers. We're working with Proterra to design and install somewhat of an overhead design because we are very limited in terms of our bus parking. We don't want plug-in chargers in front of every single bus. We'd lose a huge amount of parking space at our yard. So the design calls for an overhead structure where the dispensers will be attached to the structure and connected to the bus, to the chargers. The charger will be located in a specific location in the bus parking area. And the plugs will be on a hose reel attachment where we can just pull the plugs and plug it into the bus. So that, we're looking at $1.4 million for that whole project. So, I mean, infrastructure, design, and cost is really a very big component of fleet electrification. Recently, we entered into a contract with Burns & McDonnell to help us design our program in terms of meeting our goal of 100% electric fleet by 2030. Included in their scope of work is to look at all of our bus routes and our bus blocks and identify what routes can be electrified with the current technology. It also calls for them to investigate charging capabilities, different types of chargers, as well as battery technology. So it's a huge project, and our kickoff meeting is going to be next week with projected completion of the project by May of next year. And that concludes my presentation.
Thanks, Roland.
Jason? Yeah, you're welcome.
Okay, so real quick, I'll kind of try to summarize what we went through, and then we can get into Q&A real quick. I will say that the synthesis, I think, accomplished its goal of really providing a wealth of information about the current state of practice, or at least the state of practice a year ago. So I would encourage you guys to read through it in order to take a deeper dive about what we talked about today. But it is a rapidly evolving industry, and I think we still see a lot of small fleets that are growing, and I think we'll continue to see information. It might be time to do another synthesis here soon, but and hopefully it came across that the decision space is certainly complex for all phases of battery electric bus deployment, whether it's procurement and planning and even into deployment. And there's a number of different tools out there already, but I think there's a need for more tools to be able to really optimize the way these buses are being used and minimize the operating costs associated with the buses. And finally, I think the buses are working well in service. I did not really include reliability data or survey information in there. I should have, but in the webinar slides, but I would encourage you guys to go to the synthesis as well as the NREL reports on the battery electric buses to understand, reliability of these buses. But again, it's early, and I think we're still feeling that out in the industry. But there is certainly a need to better understand and really kind of clean up utility rate structures in some areas of the country, provide planning tools, charge management technologies, really complete our standards and guidelines while they're under work or in process. We do need to kind of wrap those up and get those out to the industry. The need to develop life cycle cost analysis methodologies, hopefully include those in standard bus procurement guidelines, so we're all kind of using the same approach or approaches. And finally, there's still a big need for decision-making support for scaling up fleets. And I think we've seen a prevalence of fleet transition studies that are coming around for individual fleets and being commissioned. But I think in terms of an industry providing recommendations and support, I think there's certainly a need for that. There's a link to the synthesis, and I think next we can go to the Q&A portion of the webinar.
Yes. Some of the questions I know were answered. Some of the people were talking back and forth. I tried to copy and paste questions out of the chat box as we went along, but because we were having technical difficulties, some of them might have gotten lost in the feed, and I apologize if I missed your question. It was a little hairier than usual today. So going back to the early part, one of the first questions looks like it was from Timothy Romero, and he asked, do these buses require the technicals to be certified to work with high voltages like electricians have?
Here at Foothill Transit, our mechanics they went through a training with Proterra. It's part of the bus procurement, provide PMI maintenance training, and we also acquired a software for diagnostics, but it didn't require any electrical certification or whatnot, because we're really not getting into the electronics of the bus. I mean, there's diagnostics that tells you what needs to be replaced, but when it comes to involved electrical componentry of the bus, then Proterra takes care of that for us. But overall, the maintenance, in terms of PMI maintenance, all you're doing is checking electrical connections and signals and things like that. You're not really cutting wires or doing really intensive electrical work in the bus. I mean, the bus is a lot less complicated than an internal combustion engine bus. There are a lot less components. And you don't even have to touch the high voltage battery. So we're not required to have specific certifications for our mechanics.
And to kind of expand on that, we see that most of the OEMs do provide that high voltage training. I mean, you do, Roland's right, but you still need to be able to work in and around high voltage safely. And yeah, most of the OEMs, all of the OEMs offer that as part of their typical maintenance training. And we also saw that agencies that had larger agencies that had rail operations were more comfortable working on those systems, but not all of them were actually, in a lot of cases they were separate departments, so they still required that that maintenance training from the OEMs. And to back up, to kind of, in addition to that, if you are considering deploying on-route charging, there was some of the survey questions dealt with that, and there was a wide variety of responses in terms of who maintains those chargers. They are high voltage systems, so kind of keep that in mind that, if you are deploying high voltage infrastructure, you do either have to procure that capability or have the OEM, have the equipment manufacturers do it, or try to take that on in-house. But there were a bunch of different approaches to that. Lori, are you there? Uh-oh, we lost Lori. Can you guys hear me?
Yeah.
Okay.
Their connection dropped.
Okay. Well, I can scroll through the chat box. Jenny Rowland asked, have the buses been tested under cold weather conditions? Yes, there are fleets in the U.S., well, maybe not down to -40, I'm not sure about that, but Fahrenheit, but Worcester, Mass has a fleet. Chicago has deployed electric buses. Winnipeg, I believe, are some of the fleets in cold weather conditions. How are they on hilly terrain? Asked Timothy Romero. What we've seen in the industry is that they have been pretty good on hilly terrain. These buses do have a pretty flat torque curve, and they can have high torque from the electric motors, but it really depends on how they're tuned. And so it is important to understand how they're going to work in your hills. We have seen also OEMs utilizing or changing over to larger motors to be able to handle some of the hilly terrain. But it will certainly affect your energy consumption as well. So it's important to understand those duty cycle requirements in terms of energy consumption and what they'll do.
With a question on cold weather testing, we do have a FTA supports the NREL evaluations of bus deployments, and we are starting the evaluation of the deployment of Proterra buses in Duluth, and that starts this fall and will go through this winter and run for a year.
Hi everyone, I'm back. I had a call back from my cell phone. The phone that I was using to host the conference call wasn't letting me talk anymore, but it's still connected, otherwise everyone would have been disconnected. So the saga of the ongoing technical difficulties seems to be continuing, but I didn't want to hang up because then everyone would be gone.
No worries.
So I guess
we're just going through with the questions from the chat.
Yes, I'm sorry. This is really, I've had difficulties before, but this has been unprecedented. So you answered the cold weather questions, right? Did you answer the questions about, was the survey only to APTA members, and were any Midwest agencies procuring surveyed? That was from Andy Fry from Topeka Metro. Did you get those?
We did have agencies from the Midwest. You can, and it wasn't just APTA members. We put it out, I think, to just about everybody. Well, actually, we did put it out to 21 agencies. But let's see, we had Indigo was actually also a case example. CTA was surveyed. You can see the map that was shown in the webinar to see where all of the agencies were pulled from.
I hope that answered. There was a conversation about overhead chargers in areas of snow. Is that the cold weather conversation that when I was trying to dial back in? Or
with the overhead chargers?
Timothy Ramirez, how good will the overhead chargers work in areas of snow?
I think, let's see, I think we asked a question about that in the survey, but in general, it depends on the configuration of the charger. But in general, I think they worked pretty well in terms of the snow clearing capability in terms of their design as they were approaching.
Jason?
And docking. Yes?
Wouldn't a pantograph up would be a better application for snowbound locations? You don't have to worry about trying to clear snow off the rooftop of the bus. Just wondering.
Probably, but they utilize basically two parallel bars that face opposite directions that are parallel to each other, and I think in terms of making contact, it's pretty reliable. I think it's similar to in terms of trolley buses.
Yeah. You just need to have the pantograph go up into the charger and connect and charge it. So.
Yeah, if you have a bus up pantograph, you do of course have to carry that infrastructure around. That's kind of the downside. But in terms of reliability, you have one on every bus. So if you have a inverted pantograph, you really don't have to carry that that equipment around. But of course, if a charger goes down, then that affects any bus that's charging at that particular charger. I think in what you'll see first out of the overhead charge committee is the charge standard for inverted pantograph. That's generally being done in Europe, and that's generally what's going to be offered with the buses that we're seeing in the U.S. that are not the blade style, the Proterra blade style.
Okay, so I'm scrolling back. These are the early on questions. There's a bunch at the end. I don't know how many we're going to get through, honestly. Yuri of Santa Rosa wanted to know if the report provided an insight into electrifying a paratransit fleet at all.
We did not. That actually was not part of the charge of the scope of the synthesis. And it's early. It's a little more difficult to incorporate an electric powertrain on the smaller buses. So the majority of the deployments have been, 35 foot, 40 foot, and articulated bus related, which we did include all of those within the survey.
Okay. David Haas had asked, has any transit running BEBs needed to replace a battery yet? If so, at what cost? I don't know if that was a question for other people in the chat box or for you guys.
So, Foothill Transit, we've had buses since 2010 when we never had to replace high voltage batteries in our fleet of buses. Proterra estimates that the battery life should last 6 to 8 years. We were at their factory yesterday visiting with city council members from the city of Duarte because we're going to be operating 3 35-foot electric buses in January. One of the questions was, what's the cost of replacing high voltage batteries? And I guess there was an article in Bloomberg, according to Proterra, that forecast the cost of batteries by 2030 to be less than $100 per kilowatt of energy. So if you're looking at 660 kilowatts at $100 per kilowatt, be around $66,000 cost. Midlife overhaul or replacement of an engine, we're doing that on some of our fleet at about 250 to 300,000 miles, cost about $78,000. So if that number comes true by 2030 or hopefully before then, it should be compatible. I mean, balance out the cost of major overhaul or replacement of an internal combustion engine with battery replacement on battery electric buses.
And we did ask, we do have some information related to how agencies were approaching the battery warranties and kind of what was being offered within the industry, but almost all of them had at least 6 years of warranty on the traction batteries, with about half of those opting to either purchase buses that carried a 12-year battery warranty or purchasing the extended warranty to get them to 12 years.
Proterra is also, some OEMs, I think Proterra is offering lease on the batteries, so your initial purchase price of the bus would be a lot cheaper, and then if you lease the battery, they guarantee the battery for life of 12 years, and if it fails, they'll, since it's on the lease, they'll replace it.
And
Okay.
sorry, one more thing on that is I think one of the other needs in the industry is information on how setting up charge schemes and charge methodologies that we kind of talked about, how those impact battery life. I mean, we know things like if we're able to maintain charge within a smaller band and utilize lower power charging, those types of activities are intended to and expected to extend battery life. But we really don't have data, especially operational data, that tells us, you know, what those impacts are and what the trade-offs are associated with doing deep discharges on the batteries. So I think that's really another need in the industry, and again, that factors into all of those other variables that will impact your decision making.
There was a question from Kara Crawford earlier. With the new overhead charging system that Foothill is planning in their depot, how many buses can be charged per hour?
So the design calls for 14 chargers with 14 dispensers installed on the overhead structure. So we're able to charge, that would allow us to charge 14 buses all at the same time. But with the way those buses are going to be blocked out, some buses will be in service, some buses won't, so we'll have the opportunity to charge some of the buses during the daytime and some at night to just to avoid in terms of getting impacted by demand charges. So you want to spread your charge throughout the day and at night. The way demand charges are calculated, if you try and charge your buses all at the same time, you get a big hit on your utility bill with demand charges.
Gunther had asked, I'd like to add the following question. Is there any information on the reliability of the different brands of buses?
We do not have that. We did not collect that data or correlate it to, I mean, we did collect reliability data, but we did not correlate it to the manufacturer, bus manufacturer.
Now, the NREL reports do collect data on miles between road calls, but those reports are done by deployment site. So some information is available by deployment site from the National Renewable Energy Lab.
And of course, you can go to the Altoona reports for the individual buses. So look at durability testing.
It's I'm having a hard time figuring out if people were just having cross conversations or if these were questions. There was, you know, it's a good robust chat going on, which is always good. So I apologize if I missed someone's question. It does look like you're talking to each other. Yuri of Santa Rosa said, our agency is looking to release an RFP for planning and engineering study to assess current grid capacity and bus yard infrastructure. They were asking for recommendations of potential firms. I don't know if that's something we want to touch on during this session. Probably not.
Sorry, can you state that one again?
He was asking for potential firms for recommendation to assess current grid capacity and bus yard infrastructure, but I don't know if we want to, you know, that's like advertising. So that should be a private conversation.
Yeah. And speaking of, actually, I don't, well, you can find our CTE's contact information at cte.tv. That's our website. If you have any questions related to the synthesis or our experience, anything related to that, feel free to reach out to us.
Do we have a slide with your contact information? Was it
You
in the
know, I
beginning, or
did
was
not put that in there. my
Okay.
my email address is Jason, Jason, at CTE.TV as in television. And my phone number is 404-808-6489.
Thank you. So if anybody has a question that I either missed or didn't get answered, because we're almost at the 2-hour mark here, if you count the technical difficulty time, that was very nice of you to offer that up, and anyone can reach out and have a further conversation with you. That's great. A few more questions at the end here. Gregory asked, what are the requirements for maintaining the OH chargers? What is the expected downtimes and cost for this?
For us at Foothill Transit, we contract with the OEM. Everybody knows we have Proterra buses, but so we contract with Proterra because the overhead chargers, the technology on those chargers that we have are proprietary to Proterra. So they do maintain our overhead chargers. It costs us, I think, about $1,500 per month for each site. Reliability, we haven't had any issues. Major issues, we've had some parts failures, but it didn't take too long for them to repair it. I mean, there are local technicians available, and they respond quickly to fix the chargers. The reason why we have 2 charging stations at each of our transit centers is for redundancy as well. So if one charger goes down, you still have another charger that you can use to charge your electric fleet. So that's why we always have 2 just to cover those kinds of instances.
Okay. Carly wrote, can APTA CTE create an inventory of which transit agencies have electric buses and what type of charging infrastructure they use?
We actually do we do a market study every year, survey every year. So you can reach out to us and we can provide that.
Great. Robert, I answered your question. Will this webinar be downloadable? Assuming the recording came out okay, which I don't even want to make that assumption at this point, I will be able to put it on NTI's YouTube page. Maybe you didn't even know we had a YouTube page. You can find the link at the top of the NTI homepage, or you can just go over to www.youtube.com and it's /user/RutgersNTI. But again, the link is at the tippy top of our homepage. And if it's available and I have a good copy, I try to post all of our webinars up there. So if you miss one, you can usually find it there. Sorry, just putting my plug in. Mary Kong asked, has there been any studies done for large fleets?
I can say that there is there's a TCRP project coming up that's still in the works. They're still in the contractor selection process. It's a guidebook for deploying transit bus fleets, but that'll be out maybe a year or so from now.
Okay, everyone has to stay tuned for that. Cindy wants to know if you've been getting bad feedback on BYD. And Gunther also wants to know that.
I would prefer not to comment on individual OEMs. We try to be independent and unbiased. But I guess I would recommend reaching out to individual agencies and yeah. and getting,
The diplomat
their
kind of answer
opinions.
there.
Yeah, yeah.
Okay, I think that was actually the last question. We'll give sort of a last call if anybody wants to. Oh, wait, Gregory has a question. Has there been any experience with mixed fleets of e-buses, 40 and 60-foot buses using the same chargers? For some logistics requirements for 60-foot buses. This is a series of questions, Gregory. Should agencies design for 60-foot Arctics? Can chargers handle dual-length buses, or would you need different chargers for different lengths? So there's, like 6 questions in there.
Roland, do you want to try to take that
Yeah,
one?
sure.
Or?
Sure. So we have 35-foot and 40-foot buses. They all charge with the same charger, overhead chargers, as well as we have a plug-in charger at both of our yards, and they use the same charger. On a 60-foot articulated, I don't think it will be any different. Depends on what kind of battery pack you have. I mean, if it's an extended range, 440-foot kilowatt, you could still use a plug-in 60-kilowatt charger. The style of the bus has no impact on what type of charger you're going to use to charge a bus. As long as you have the same plug, I mean, if they're all J1772, that's works perfectly fine. What will impact the charging would be the amount of time it'll take you to charge the bus. It depends on how much energy those batteries carry in your bus.
And I can speak from the individual SAE committees. That's the goal, is to ensure interoperability among bus sizes and manufacturers. That is the ultimate goal.
Okay, the next question came in from Lawrence Mason. I've seen questions about cold weather and extreme heat. Have any buses been impacted by flash floods or heavy rain? Good question.
No flash floods or heavy rain in our neighborhood, so I can't say anything to that.
No, none of that was reported. However, we do know that with fleets, there are large fleets with hybrids, and they have, of course, Houston Metro, of course, has a pretty big hybrid fleet, and I know a lot of agencies will try to move their buses to high ground, if they do have batteries on board, high voltage batteries on board, but there are IP ratings that are required for a lot of the enclosures for the high voltage components, but I haven't heard of any major issues to date, whether it was through the survey or other work.
Andy Fry asked, beyond Southern California Edison's electric rate, do you know of any other examples of non-municipality utilities creating transit-specific electric rates for electric buses?
Not to my knowledge. I know there are agencies, utilities. Almost all the utilities across the country are aware of the need for transit-specific rates, and even taking on providing electricity as a service specifically for transit buses. But I don't know of any others that have a transit-specific rate in place.
And Yuri asked, how about emergency planning? Does the study review how to ensure fueling during major long-term loss of power?
Actually, we have not. Unfortunately, we have not seen any plans developed for long-term loss of power. Again, I think that's one of the things that need to be developed for scale up. I think there are some initiatives that are going to be in place to hopefully do kind of a cross industry working group to try to address some of these questions and issues related to long-term loss of power and blackouts, brownouts, that sort of thing. But I am not aware of any plans that are currently in place.
Okay. Andy says, this is for informational purposes. So it's not really a question, Andy. It says, for informational purposes and to toot Topeka Metro's own horn, since we don't yet, whoops, it's scrolling away from me, yet have buses. We have worked with Westar out of our local utility to get such a rate I was asking about. We would be happy to talk with others, oh, it's scrolling, others on ways to work out something like that. So everyone interested in that, get in touch with Andy Fry from Topeka Metro. That wasn't a question, it was more of a comment. Gregory asks, Gregory is commenting also about deals cut between agencies and LRT services, about a tariff, using a particular meter. Should I read comments or should we just go to questions? It's, you know, it's getting late, so I'm sort of trying to be cognizant of the time. We've lost quite a few participants. What do you think?
I can keep going. If
Okay.
everybody else can, or I mean,
Yeah,
we have been going at this for 2 hours.
I know
So,
our captioner was only reserved for an hour and a half. So I thank you, captioner, for still staying on and typing. I know you were only reserved for 90 minutes. Okay, so it looks like Jason and Andy are chatting happily. Oh, I got a PM from Mariella saying thank you from TRB and TCRP. Thank you to Jason and all the panel members. That was from Mariella.
oh, that's great. Mariella was, yeah, great working with at TRB. She was the manager for this particular synthesis.
Yes. So she sent me a message. She wants to thank everyone. Tim says, does replacing batteries during a midlife refurbishment extend minimum useful life of a BEB?
All right, say that again. I'm sorry.
Sorry, I'm eating candy corn. Does replacing batteries during a midlife refurbishment extend minimum useful life of a BEB?
No, I think it's still 12 years for a heavy-duty bus, if I understand the question correctly.
Tim, I hope that answered your question. And that was
Don,
actually
do you?
it.
Yeah, I think that's... Okay.
All right, are there any more questions? Type now or forever hold your peace. You also have Jason's contact information, and you can also get in touch with me. My name was on the emails you got.
Yeah, and thanks to everybody who provided information for this synthesis. Thanks to the panel. Thanks to all the agencies that were really open and honest in their responses, and the agencies that sat down and provided case examples, and the agencies in particular that are out on the leading edge of deploying this technology and really finding out about a lot of the things that, you know, we need to understand and are pioneering for all of the rest of us. So really want to give a big thanks to them, as well as FTA for really really engaging and kind of kicking off the what we see as a burgeoning industry and clean vehicles. So certainly thanks to everybody involved.
And to continue the thanks, I want to thank everyone. That would be Jason, Roland, Sean, and Jeff, for your presentation, and all the participants for your patience and perseverance. We did the best we could with the circumstances as they were. For anyone still listening, you will be receiving an invitation to fill out an evaluation. We greatly appreciate your feedback. So if you just take a couple of minutes and fill that out when you get it, that would be wonderful. Anybody else? Parting words?
Yeah, thanks, Lori, and thanks everybody
Thanks.
else.
Sorry, I did my best.
Thanks, Lori.
Yep.
Thanks, everybody.
It was a good session here.
I think it was really, considering, I think it was great.
Yeah, I thought it went really well. Rough start, but hey, that's okay. It happens.
It does happen. I'm
It
sorry.
certainly does.
We're going to look into it. I hope so. I think we did. All right, everybody have a great afternoon, and keep up the good work.
You too.
Thanks.
Talk to everybody later.
Thanks.
Bye-bye.
Bye.
Bye-bye.